Okay, so this will be the last lesson for chapter 5, and we are going to look at our graphs and find our x-intercepts, our max and mins, and talk about end behaviors still, and then do intervals of increasing and decreasing. And then we're going to also look at, if I give you a table, how do you find the function for that given table? How do you know what type of polynomial it is, and how do you get the function? Okay. So your x-intercepts, you know where, or what an x-intercept is. It's where the graph crosses the x-axis. Now, if you have a double solution or any solution with an even exponent, remember that it doesn't cross. It just bounces back and touches. Okay, so that's still considered an x-intercept. Your location principle reads that if f is a polynomial function and a and b are two real numbers, that a is less than 0 and f of b is greater than 0, meaning if you have a negative y value and a positive y value, then you have to have a 0 between those, right? The only way you can cross the x-axis is if your y value is changing signs from positive to negative or negative to positive, okay? So that's just where if I am giving you a table and you have a positive y value and the very next value is a negative, then you know somewhere in there is a 0, okay? If I needed you to estimate where one would be, that's how you could do it, okay? Your local max and min is just a turning point on your graph. So you should be able to look at a graph and identify where is a local max and where is a local min, okay? It doesn't have to be the highest or the lowest point. It's just a turning point that can be a high point and a low point. So for you to have a maximum or a minimum, you would have to change direction completely. So for a maximum, I would have to increase and then all of a sudden go right back down and decrease. That would be my max. Okay, for a minimum, I'd be decreasing, then all of a sudden go back up to increasing. So that would be my min. So I have a complete change in direction. Okay. Now, there is a rule that you can kind of estimate what type of degree you have according to your turning point. So it says the graph of every polynomial function of degree n has at most n minus 1 turning points. If a polynomial function has n distinct real zeros, then its graph has exactly n minus 1 turning points. Basically, think about if I have a linear function, that's a straight line. Okay, that degree is 1. Do I have any turning points on a straight line? No. If I have x squared, that's a parabola. How many turning points do I have for that? I would have 1. It would either be my vertex, which is a max or a min. Okay? If I have a cubic, then I should have 2. Okay? Do you see? So you always have 1 less than your degree for your turning points. Okay? So when you do your max and mins, I want to see it as an ordered pair. I don't want to see a y value. Okay, when we did quadratics, we said a max at y equals something. Okay, we're going to do actual ordered pairs for this. Okay, now your decreasing and increasing intervals, your interval is for your x values. Okay, so we're going to read our x-axis, and those x values are going to be what your intervals are, but you're going to be looking at up and down for your y's. Okay, it's really not hard if you just know your intervals or your x's. Okay. Now, we usually do, like, domain and range interval notation. We would do brackets if it's included, but for right now, we're just going to do parentheses because it's just an interval. We're not saying what's included, what's not included, okay? So if I look at this right here, okay, I have an x-intercept right there, right here, and right here. I have 3 x-intercepts. And I have 2 turning points. So this is probably a cubic function, okay? Now, I don't have the exact points right here, but I could probably estimate that this would be around negative 1.75. This would be 0, 0, and this would be 1.75. Probably around that area, if I were to guess. Okay? Now, this point right here would be a local max. It's a high point. I'm increasing. I hit that point, and then I turn down to decreasing. Okay? And then I have a local min right here. So my max is at -1, 2. My local minimum is at 1, -2. So if I were doing an interval on increasing and decreasing, these x values for my max and min are pretty much like my breaking points of those intervals, right? Because I'm increasing all the way up to that one point. So if I were to do an interval on my increasing and decreasing, I'm only including my x values, well, all the way from the left up until I reach -1, 2, I'm increasing. So if I'm thinking on my x-axis, the left is -infinity, the right is +infinity, my interval for increasing would go from -infinity to that x value of -1. So I'm increasing there, and then I start to decrease from -1 all the way down to my minimum. I don't go any lower than that because that's what a minimum is. So my decreasing interval would be from -1 to 1. Then at my minimum, since I don't go any lower, it's only up from there, and so I'm increasing from that value all the way up. So I'm going to add another increasing interval from 1 to +infinity. You understand that? Very simple. Okay? Alright, so if I look at this next graph, I have an x-intercept here, an x-intercept there, x-intercept, and x-intercept. I have 4 x-intercepts. Okay? And I have how many turning points? 3. So I at least would have a 4th degree function. Okay? So if I'm looking at my max and mins, I have a minimum right here. I have a maximum right here, and another minimum right there. So my increasing, we're not going to do the interval because those are not set points, and I can't see what those are from the copy machine. My original is clear, but it's fine. You would go decreasing from -infinity all the way to that x value. So let's just say that's -1.5. Okay? And then I would increase from that -1.5. That's really not 0, but we're just going to say it's 0. Okay? Because you would increase all the way up to that maximum. And then I go back to decreasing from that maximum to this minimum. And then I go back up to increasing. Okay? If you want 2 colors, I just didn't grab 2 colors. But if you want 2 colors for your increasing, decreasing, you can do that. Y'all understand how you would do that interval? We don't have the set values, but... So what we're going to do, it says graph each function, identify the x-intercepts and the points where the local maximums and local minimums occur, determine the intervals for which the function is increasing or decreasing. If I give you this function and I tell you to graph it, but I'm not giving you a graphing calculator for this specific, yes I am. Yes I am. We're not going to factor. Yes I am. Okay. So, if I have this, I'm going to graph it. I couldn't remember what we're doing graphing and what we're doing not. Okay? Your graph should look like mine. I only have one x-intercept on my graph, but I have a cubic function. What do I know about my other x-intercepts? They would be imaginary. If they're not on my graph, they're imaginary. Okay? So I'm going to find my x-intercept by doing menu 6 enter. Remember, y'all scroll to the left of the x-intercept, hit the middle button, scroll over to the right. Y'all remember that? Okay. So my only 0 is at negative 1.20. Now I need to do my local max and my local min. So to find your local max, yes, I can look at this and identify it, but if you want to be accurate, you can do menu 6, and then maximum is option 3. And you treat it the same way you do zeros. You go to the left of it, hit the center button, scroll over to the right of it, hit the center button. So your local max is 0, 6. And do the same thing for my minimum, menu 6, but now my option is 2. So menu 6 will give you your x-intercepts, your maximum, and your minimum. Okay? And you do all the same steps. Go to the left of it, scroll over, go to the right. So my local min would be 2, 2. Now notice I don't have numbers on this. Just assume it's going by ones. Okay? We're sketching it, so we're going to look at where is my 0, where is my max and min, and then you're sketching it from there. Okay? If you wanted to adjust your scale to make yourself happy, you could. I'm just going to go by ones. So a negative 1.2 is going to be about right here. Then 0, 6, and 2, 2. So your graph should resemble what this looks like. Okay? Now you have the graphing calculator. If you wanted to get the table and be super accurate, you can. But I'm going to be looking at this. So when I do my interval for increasing and decreasing, I'm going from negative infinity to positive infinity. Okay? If I start at the left, I'm increasing up until I get to 0, 6. So I'm going to increase from negative infinity to 0, because I'm only doing x values. Your intervals are x values. Okay? So if you need to trace, that's what I was doing. If you need to trace your max and min back down to the x-axis, and you need to put your 0 and 2, those are my breaking points of my intervals. I should go to 0, whatever it is, it should go to 0. I should have something from 0 to 2, and then something from 2 and positive infinity. So it's like you're breaking it in parts, okay? So I'm increasing up until 0, and then from 0 to 2, what is my graph doing? I'm decreasing. And then from 2 onward, I'm going back to increasing. So 2 to positive infinity. You don't have to highlight it. I'm just doing it for you to see what's going on. Okay? Now, if I asked you to do in behavior, could you do it? F of x is going where as x approaches negative infinity? Negative infinity. And f of x approaches what as x approaches positive infinity? Okay. Alright, next example. I'm going to clear my calculator, graph the function. Once you graph it, we need to find our zeros. Now, if you want to round to -1, because one decimal place is going to still be a 0, it's up to you. But I'm going to just put the 0.04. I'm never going to write more than 2. So you can either round, if your instructions do not specify, I would round to either 1 or 2 places behind the decimal. So I would make that next one 0.30. You're all comfortable finding zeros in your calculator. Okay. So then once I do that, I know I'm going to have, I can tell from my graph, I have 3 turning points, but my graph does not show that. Okay? So if you need to zoom out, do menu, 4 is your zoom, menu 4, and then 4 zooms out. And I'm just going to click on the center because that keeps it centered. I'm going to zoom out from my origin. If you need to zoom out some more, do it again. Okay? To get out of this zoom, see how my thing is still with that hourglass? Hit escape and it will make it go away. Now I'm going to hold on to all of these. If it'll let me. It's not going to let me. There we go. I'm going to move them so I don't get... So when I do my menu 6, 2 for my minimum, even though it's very zoomed out, I'm going to go somewhere to the left of that minimum and somewhere to the right. And so that minimum, I'm going to round to negative 0.5. I'm going to just round that to negative 6. And I have one more minimum that I need to find. So menu 6, 2. I'm going to go to the left, over to the right. I'm going to round that to 3.6 and negative 14.2. Y'all follow me? I know what I'm doing? Okay. And then I'm going to do my maximum, menu 6, 3, to the left and over to the right. So we're going to say that's 1.4 and 8.2. Now, if you want to zoom back in, you're going to do menu, go back to zoom. 5 is standard. So if you want to go back to your normal screen, menu, then zoom, and 5 will put you back at standard. Okay? I only have 8. I would change your scale. Unless you want to just go off the graph, I'm going to change my scale. Okay? You can go by 2s so that you can cover this negative 14. Okay, so I'm going to do, if you change your scale, please make sure that you put it on there. And my X's I'm going to leave. Unless you wanted to change those. It's up to you. Okay, so for here, I've got a 0 at negative 1.04. So that's going to be pretty much negative 1. Then 0.3 to 0.4. And 4.4. Then negative 0.5 to negative 6. Okay, then we're going to do our interval for decreasing and increasing, starting from the left. So from the left, my first dip is a minimum. So that means I'm decreasing from my left all the way to what X value? Negative 0.5. So I'm decreasing from negative infinity, which is my left, to negative 0.5. And from negative 0.5 to my next high point, I'm increasing. So I'm going from negative 0.5, my maximum is 1.4. Then I decrease again from that 1.4 to my next minimum at 3.6. Then from 3.6, I just start increasing. So 3.6 to infinity. So the X values of your max and mins should be the values in your increasing and decreasing intervals. Are y'all noticing that? Okay. Are y'all good? Do we have questions? Okay, now we're going to talk about even and odd functions. This is not even and odd degrees. Okay, even and odd functions. A function is considered to be even if your original f of x is equal to f of negative x. Okay? And a function is considered to be odd if your f of negative x is equal to negative f of x. Okay? Now, we just did transformations, right? What is f of negative x? What type of transformation is that? A reflection over my y. What is negative f of x? Okay, that's really what's going on here. Okay? So what we're going to do is find our f of negative x and compare it to your original. If they're the same, then that would be an even function. You wouldn't have to go further. If they're not the same, then you find negative f of x, compare it to your original, not your original, your f of negative x. If those are the same, then it's odd. If neither work, then it's neither. Okay? So if I have f of x equals x cubed minus 7x, I'm going to find f of negative x. So that's negative x cubed minus 7 times negative x. So f of negative x is equal to negative x cubed plus 7x. So I'm going to compare that to my original. Is it the same? No. So it's not even. So now I need to find negative f of x. So negative, and then in parentheses, x cubed minus 7x. So negative f of x is equal to negative x cubed plus 7x. So I'm going to compare that to f of negative x. So many negatives. Is that the same? So it would be considered odd. So we have three things we're looking at. We're looking at our original. We're looking at f of negative x. And then negative f of x. Okay? So if I have g of x is equal to x to the fourth plus x squared minus 1, I'm going to find g of negative x. So negative x to the fourth plus negative x squared minus 1. So g of negative x is equal to x to the fourth plus x squared minus 1. Is that equal to my original? Yeah. So it's even. So now h of x equals x cubed plus 2. I'm going to do h of negative x. That's negative x cubed plus 2. So that is negative x cubed plus 2. Is that equal to my original? No. So I'm going to find negative h of x. So negative, in parentheses, x cubed plus 2. Negative h of x is negative x cubed minus 2. Is that the same as h of negative x? No. So that would be neither. So this is why you can't just go off of degrees. You're actually finding if those would be equivalent. If they are, then there's your odd and even. It's that simple. Okay? Alright, your finite differences. If I give you a table and your x values are equally spaced out, so they're all going by 1s, all going by 2s, you have a constant change in your x's, then you can find your differences of those consecutive y's, and that's called finite difference. Okay? We're going to use those finite differences to find what degree of this function is it. Now, these first two examples, I'm telling you, this is a linear function, this is a quadratic function. But on your worksheet and the next example in the notes, And on the test or quiz, I'm not telling you that. Your instructions will say use finite differences to determine the function or something in those words, okay? So what we're going to do is, knowing that it's linear, we're going to verify with finite differences so you can match it. Knowing it's quadratic, we're going to use finite differences to verify it is, okay? So all you're doing is subtracting your second y value and your first. So right minus left, okay? 1 minus -1 would give you 2. So you're seeing, what are you doing each time with your y's? When I jump 1 to 3, I'm jumping 2. If I jump 3 to 5, I'm jumping 2. I shouldn't say jumping. Technically and mathematically, that's not correct. I'm adding 2. Okay? 5 to 7, I am adding 2. 7 and 9, adding 2. 9 and 11, adding 2. Notice that they're all the same. And I did one round. So one round makes it linear because it would be a first degree. Okay? Now I'm not doing the algebra and doing the slope and point slope form and all that to get the linear equation. We're going to use our calculators to get the equations. We just have to figure out what degree is it. Okay? So if I do one round and it's linear, now I'm going to look at this next table. My x's are good. So my y's, if I'm going from 6 to 1, I'm subtracting 5. From 1 to -2, I'm subtracting from -2 to -3, -3 to -2, plus 1, -2 to 1, 1 to 6. It's definitely not the same. So I need to do another round, and we're going to subtract these. Okay? So if I go from -5 to -3, -3 to -1, -1 to 1, 1 to 3, 3 to 5, now those differences are all the same. So I did 2 rounds. There's my quadratic. Okay? All right. So your instructions: use finite differences to determine the degree of the polynomial function that fits the data, then use technology to find the polynomial function. Okay? All of this I'm going to walk you through on the calculator. I'm not reading that. Okay? So we're going to start with finite differences. I know my x values are good. So from 1 to 4, 4 to 10. So we know it's not linear. Okay? 10 to 20, 20 to 35, 35 to 56, 56 to 84. Okay, so we do another round. 3 to 6, 6 to 10. So we know it's not quadratic. 10 to 15, 15 to 21, 21, 28. So we do another round. 3 to 4, 4 to 5, 5 to 6, 6 to 7. So I did 3 rounds. So that's going to be cubic. Okay? So in your calculator, you're going to go home, and you're going to go to the spreadsheet. Y'all remember doing quadratic regression? Okay. If not, we're going to do it. You go to that spreadsheet. Before you do anything, you got to go up to that A, and you put X. Oh, I don't know what just happened there. X, enter. And then you make your B column Y. Then for your x column, you do your x's. 1, 2, 3, 4, 5, 6, 7. Then put your y's. Now, what happened with a lot of y'all is with your quadratic regression, you would just do your regression in any cell. Go to C1. If you make a habit of going to C1, then you don't have all the weird stuff going on. Okay? C1 is a blank cell. It's at the top. Everything should work. Okay? So we're going to go to menu 4 is statistics, menu 4. Stat calculations. See how you have quadratic, cubic, and quartic? So the finite differences tells you which one you're going to choose. Okay? I have a cubic function. So I'm going to choose cubic. My x list, we're going to do x. Y list, we do our y. Y'all vaguely remember this now? Enter, enter. Now, if I'm doing cubic, that's y equals ax cubed plus bx squared plus cx plus d. We just move on with the alphabet. Okay? So what my calculator does is gives me those coefficients. Okay? So we're going to round, it doesn't specify, I'm going to say we're rounding to 2 places. Okay? So I'm going to have y equals, my a is 0.17 x cubed, plus my b is 0.5 x squared. Does anybody not have these values for a, b, and c? Okay, so you're in, okay, and it says x list, you make that x, type x. Then for y list, you type y, and then enter, enter. So then my c is plus 0.33x. Now I'm going to have to scroll. Now, negative 7 with e to the negative 12. That e to the negative 12 is what? Times 10 to the negative 12. What is that? What's negative 7 times 10 to the negative 12 rounded to? 0. So you don't need it. I know y'all have gone over scientific notation in chemistry. Okay. Y'all good with that? You're going to have a quiz over this next class, and it's review day.